This semester, EPICS 494 team Water in Peru has partnered with nonprofit 33 Buckets to design a water disinfection system for communities in the Cusco Valley of Peru. In the summer of 2018, two of the EPICS team members were able to travel with 33 Buckets to assess current infrastructure and begin designing a solution for community-wide clean drinking water. Bacteria tests performed on samples taken from the tap confirmed the presence of E. coli bacteria in drinking water. Current disinfection methods include a liquid drip chlorination from above the reservoir. However, dosing is arbitrary, and there is no structure for testing and monitoring of water quality over time. The Water in Peru team is proposing a tablet disinfection system that allows for continuous disinfection in the existing gravity-fed infrastructure. The design also includes a chlorination valve that allows for easy adjustment of chlorine dosing in the reservoir. The proposed design also includes solar-powered residual chlorine sensors that automatically collect the residual chlorine levels in the water and display the results to the user. The ultimate goal of the system is the effective disinfection, testing, and monitoring of a community's drinking water over time. A chlorination system is displayed here, running continuously with pool water and no chlorine tablets. The system is equipped with two valves, one for the primary flow and one for the flow into the chlorination system, which is shown here without a cap to observe water flow. When the chlorination valve is closed, the volume of water exposed to chlorine is restricted, and the overall residual chlorine of outcoming flow is decreased. We set up a small volume of tap water to run through the system to show proof of concept that the system increases chlorination levels. A single calcium hypochlorite tablet has been placed in the tablet tube.
We have designed this tube in a way so that it holds the chlorine tablet in place while also fitting in the larger system, making it easily accessible for people.
The chlorine sensor is an all-solid-state electrochemical sensor designed to complement the continuous chlorination system. It measures the electric potential response to the change in residual chlorine levels of a water sample. Some research led to a suitable electrode pair whose potentials change at differing rates depending on the amount of chlorine in the water, but change at the same rates with regard to other environmental factors such as pH, dissolved oxygen, and temperature. Electrically, probes made of these two materials are then submerged in water samples, and the resistivity of the water is measured utilizing a Wheatstone bridge. The sensor then goes through an instrumentation amplifier to allow the ADC to measure the small voltage changes seamlessly. An Arduino then outputs the chlorine level to a display.
The purpose of chlorine disinfection is to inactivate bacterial pathogens from water sources. This method is commonly used in drinking water plants, pools, and rural drinking water systems because of the widespread availability of chlorine. When chlorine is added to water, it reacts with a variety of substances like organic and inorganic material and metals before disinfection begins. The remaining amount of chlorine is known as total chlorine and is the concentration after the chlorine demand is met. This branches off into free chlorine and combined chlorine. Free chlorine is the most important as it is the concentration of chlorine available for disinfection. Chlorine comes in several forms like powder, liquid, gas, and tablets. In this system, we'll be using calcium hypochlorite tablets to increase the chlorine levels. Calcium hypochlorite reacts with water to produce calcium ions, hydroxide ions, and hypochlorous acid. Hypochlorous acid dissociates into a hydrogen ion and a hypochlorite ion. Free chlorine levels are determined by the amount of hypochlorite ion and hypochlorous acid. However, hypochlorous acid is a much more effective disinfectant. A complete reaction occurs at a pH between 6.5 and 8.5, and disinfection overall is more effective with lower pH.
Residual chlorine is the amount of free chlorine left in water after disinfection has occurred. This value can be an indicator of clean drinking water and is what we are testing for in the experiment performed. The World Health Organization has set a standard of a minimum of 0.2 milligrams per liter for potable water.